I'm gonna riz up everyone.
Go for it.
All right. So we have the logistic growth model, and our problem was a lake has 100 trout and grows 70% per year and can sustain a maximum of 2,000 trout. How many trout will be at the lake during years 1 through 5? So for our equation, we have Pn equals Pn minus 1 plus R, parentheses 1 minus Pn minus 1 over K times Pn minus 1. And N means time, and N like minus 1 means time. R means growth rate, K means carrying capacity.
Carrying capacity.
And that's the formula that we're going to use. Okay, so that's what it looks like. It's A-okay because I did. So this is our formula. So when we plug it in, we're going to put 100 trout here because that's the starting number. And then for growth rate, it's 70%, so we're going to put 0.7. And then for the carrying capacity, we have 2,000. We can have 2,000 trout, so we're plugging that in right here. And then with everything plugged in, you would put this into your calculator, and that would give you the number 166.5, which is our answer, but we have to round up because you can't have half a fish. So we're gonna put 167, and that's gonna be for P1, so that's after year 1, and then that would be our new starting number for P2. So then when we plug that in, and that's the only variable that changes, all the other variables are the exact same. So then we would plug that in, and we would put that into the calculator, which would give us 274.138, and we would just round down to 274. And after this, it stays the exact same, so you would plug this in to here, and then with your new number, you would just keep plugging that in and getting the exact same thing. So for P3,
when you plug it in, you get 440, and then for P4, you would plug it in and you would get 680, and then for P5, you would get 994 after rounding up or down for each one.
Paul Regier.
Okay, now model the same fish population growing 70% per year without constraint and calculate the number of trout after years 1 through 5. And this time, without constraint, means that there is
Carrying capacity.
no carrying capacity. So instead of being logistic, this would be exponential. So we've used the equation for exponential, and after 1 year, we got 170 trout. After 2 years, we plug in that 170 here to get 289.
Keep putting in. Keep putting in.
And that's how many trout you have after 5 years. I'm done.
I think we got it.
3, 2, 1, go.
The blue line represents logistic growth, the one with the carrying capacity.
Carrying capacity.
While the orange line represents exponential growth, the one with no
Carrying capacity.
Doctor here, I know you're watching. The blue line that has the carrying capacity plateaus at year 5, while the logistic growth orange line just completely goes with no limit. And that's going to be the difference between the two logistic and exponential lines.
I'm in the club, yeah, I'm living that. When I'm at the house, yeah, I'm living that. 365 party